everybody, and thanks so much for joining us today to learn a little bit more about Azure Static Web Apps. I'm Stacy Cashmore. I'm a Tech Explorer DevOps at Omniplan, a financial software company based in Amsterdam in the Netherlands. I've been programming for far too many years, and since 2020, I am shocked and honored to be able to call myself a Microsoft MVP in developer technologies. And with me today, we have Thomas.
Hi, Stacy. My name is Thomas. I'm a product manager on the Static Web Apps team, and I've been on the team for the past 2 years. We've been working on shipping a bunch of great features that really help with the productivity and let us building applications very quickly and with that global distribution. And so, yeah, I think I'm super excited for the demo that we have cooked up for everyone today.
Absolutely. Why don't we bring up the app and we have kind of a starting point. I've been playing around with the To-Do app, because everybody does demos in To-Do apps these days. So I've written this in Vue, which is not a language that I'm experienced in, but I fancied a bit of a challenge. And we have a To-Do app where we can enter the to-dos. So we can do our introduction, we can show the app, and we can delete our to-dos. Now, this is all running inside the browser at the moment, which is, it works, it does what it's supposed to do, but I'd really like to be able to save my to-dos so I can come back to it later, because right now, if we hit F5, it's all gone. Now, normally at this point, I would start writing my Azure functions and connect them up to my CosmosDB database in order to access everything, but Thomas is going to show us a way better way of doing this.
Yep, exactly. I'm going to show how we can use database connections, a feature of Static Web Apps, in order to really easily have API access to our database without having to write a bunch of boilerplate CRUD code in order to have access to that. So what we have right now, and I think this is the database that you created for us for this demo, Stacy, is just a list of to-dos in our database. So right now we have a CosmosDB database. We have a list of to-do items, and then here, we have just some sample data. If I refresh that right now, I think we only have a single to-do. And here, if I zoom in a little bit, just to make it easier to see, every to-do has an ID along with an accompanying user ID, and then we have a label for the to-do, and then a completion status under complete. And so what we're going to do is we are going to use database connections in order to provide an API access, in this case, a GraphQL API access to this database. So we're going to be able to make this CRUD level access via that database connections GraphQL API. Now, what I'm going to do is, in order to get started with this, I'll bring up our code. And right now, we basically have our to-do list code, right? This is what we were working with. This is our to-do list.view, making a bunch of different calls to create to-dos, update the to-dos. And what we're going to do is we're actually going to be using the SWA CLI in order to emulate the database connections that we get when we deploy our Azure Static Web Apps.
Now, get more awesome functionality from the SWA CLI.
Yep, absolutely, absolutely. And so I already have the SWA CLI installed, but if you don't have it, make sure to install it so that you can emulate this experience locally. And what I'm going to do is I'm going to call the SWA DB init command. Now, the DB init command will just scaffold the configuration that's needed for this, the data source, and also a couple of the additional configurations that are needed for this feature. So if you see, we went ahead and created, you'll see that there was 2 configuration files that were created within this SWA DB connections folder. So let's take a look at that. First, we have the staticwebapp.database.config.json file. Now, this file is really to establish the connection with the database. In here, you'll see that we have the option to put in a connection string. And what I'll be doing here is instead of directly indicating my connection string, which I could do, but in order to avoid leaking any of my secrets, I'll be referring to an environment variable. And you know what? I will also go ahead and establish that environment variable in my terminal. Now, of course, I've leaked my secret, but don't worry, I'll have deleted that by the time this demo goes live.
And at least it's not in your code.
Yep, no, exactly. I won't be backing up anything to Git or committing anything into my repository. In this case, I can indicate that I have a container, which was to-do items, and then we have the database, which was demo. Now, one of the more interesting parts of this configuration file is here towards the bottom, we have the entities object. In the entities object, we can opt in to exposing any of our database entities to database connections, right? So by default, none of them get exposed. You really have to opt in for security purposes, and this allows you to have that fine-grained control over what you do want to expose. In this case, I'm exposing the to-do items, which matches the specific source of to-do items in my CosmosDB database. And I'm just going to give any user, all CRUD access for this. And here's actually where most of the heavy lifting happens, is where we indicate which entities we do want to expose. And then, probably the last thing for this is, in order for me to show you the full potential of database connections, I'm going to switch the mode to development mode. This will give me the chance to show you a little bit more of the development aspect and the developer experience that we do get out of the box with database connections. So this was just a configuration file. You may have noticed that there's another file, this .gql file. It's really just there to indicate the schema of our database. So as you know, CosmosDB as a NoSQL database, we can't necessarily extract the schema from the CosmosDB database. So we do need to indicate that here in the schema file. This matches exactly what was in the CosmosDB. But yes, for the other databases that database connections support, this isn't needed. But for the case of CosmosDB, we do have to indicate that, since it's a NoSQL database.
Makes sense.
Yeah. Now, what we have with this is we now have the database connections configured. What we can then do is run our SWA start command. So let me see if I still have that up here. Yeah, we're going to be using SWA start. This is going to be what's going to allow us to emulate the static web app experience. We are going to point our app dev server URL to the localhost 8080, which is already running here. And I'm going to indicate the data API location, right? And so this is the location of this folder here. In this case, it's just /SWA connections, and I can press start. And what this will do is it's basically going to provide us this fully emulated experience, and it's going to spin up the database connections that are required in order to have that experience emulated locally.
You've got to love the SWA CLI, the amount of things that you can do with this, from development to deployment to initializing your project. Such a fantastic tool.
Yep, absolutely. And so now let me go ahead and check it out. Let's see if we have this working. OK, so we have the application working here, and we have these requests being proxied to our view server. And I think what we'll want to focus on now is taking a look at what we get out of the box in terms of GraphQL APIs with our database. And so if I've configured everything correctly at this point, I should be able to refresh the page. And since I'm in development mode, I get this really beautiful IDE where I can test this GraphQL API. So in the operations, I can go ahead and test some of these, right? So you can imagine I have a get. And in the get, I can specify, hey, I want to get my to-do items, get specific attributes of the to-do items. And this is the power of GraphQL. You can indicate what you want the response to return. So in this case, if I did want the user ID, I can just edit that query. And as you can imagine, we have a list of either queries where we can get to-do items or unique to-do items, or also mutations. And so we have access to all of these APIs out of the box with database connections. And now we can actually call them from our code.
And it's cool, really cool that we have GraphQL here. We don't actually have a GraphQL database. We have a CosmosDB SQL API, but we can use GraphQL in order to access it, in order to get that control that we need when running the app.
Exactly. And we didn't need to build out a whole GraphQL server and have specific resolvers resolving a query to a specific CosmosDB field. Instead, we just use database connections, and we already have that GraphQL API that's already ready for us to use in our application. And that's actually really easy for us to do at this point. And I want to show you how we can go ahead and call these from our application if you're ready, Stacy.
Awesome. Yes, let's go.
Okay, excellent, excellent. Let's do it. I'm going to pull back up my VS Code. I already have my database connections configured. Everything is running great. And now all that I have to do is call this set of APIs from this to-do list.view application. Now, what I've done is I've added I've added just a couple functions that will be making these API calls. And so let's step into the list, which is a simple get. Let's dissect this. I'm just going to give us a little bit more space to see. And let's dissect what this function does. First of all, we're defining a query. This is the GraphQL query that is going to allow us to indicate what specific attributes of our items we want to receive. And you'll actually notice that this should look familiar because I just showed you something very similar in here where we're making a query to get the to-do items and receiving the items and indicating which attributes we want back. So we start off by defining this query. And then, of course, we're going to be making a fetch request to the specific /data API /GraphQL endpoint. Now, /data API is by convention, this is the sort of the subpath that we've dedicated within Static Web Apps in order to handle the database connections feature. And in this case, we're accessing /GraphQL. So this is the endpoint we're going to be calling. Just due to how the GraphQL protocol works, we are making a post request and passing the query through our body. And after that, what we have is our response.json, where we can have access within the result to the to-do items and then accessing the items. And
nice. So that would be the data API. That's the same as the .auth, the /API that we used to have previously.
Yeah, exactly.
So that's all that same convention-based URLs, which is why the SWA CLI can actually do this so well for us. And the last one that I just really want to touch on, the GraphQL endpoint that we have there, that is the same name that was used in the configuration file. So you have control over that. Is that correct?
Yes, you actually have eyes of a Lynx. That is a good catch. Yes, absolutely. This is configurable. If you do want to specify the specific GraphQL path, you can indicate that here. And so in this case, I just left it as is. But if ever you wanted to change that, you can change that definitely. Yeah.
Awesome. That's really cool.
Yeah. And so now that we have this list function, what we can do is we can call it from anywhere in our application. And so what I'll do is within my view, when my view component gets created, I'll actually call my list function in order to set the to-dos to retrieve those that are in my database and then return that and display that to our user. And so if we load back up our application, we head over to localhost 4280 and we refresh the page. There we go. We already have this item, which was in our database. So if I show you the network call and refresh the page, we are making a GraphQL call and we are receiving this specific item specifically from our database. And so if I refresh here, once again, this is this specific item show list from database that we have here. There we go. We just got our get working.
So easy that would be a whole deployment and other stuff that you need to do in order to get your Azure functions working there with everything you've got to do for all the SQL integration. And yeah, this is just a few lines of code. It's fantastic.
Yeah, exactly. And so, hey, we've done it with our get or our query, and we can also do this with our mutations, right? And so I showed you just the list to start, but I also have added a function to update where we're calling the GraphQL mutation. And then we are taking in the specific to-do ID along with the new data. And we have our specific mutation indicated here, where we can pass along the ID along with the new data. And then we just package that up. We package that up in the body of our request alongside the query and the variables that are to be injected within this query, right? So the ID is mapping to the ID, the partition key value mapping here, and the item mapping here. And then we will be able to call the update. And similarly, we do this with a create, where we can have a mutation to create new to-do items, passing along the variables and then making a post request. And then the same thing with the delete, right? I mean, they're all pretty similar. Once you have an update, you basically have a delete. And once you have a create, you basically have an update. And so what we can do now is actually call these from our database.
And an important one for people to remember there, you mentioned it before because of the convention for GraphQL. We're using post commands here, so we're not using get, delete, put, and post.
That's correct.
Everything is a post request here.
That's correct. And we're actually using just fetch, right? We're keeping things super bare bones. But if we wanted to, we could be using a GraphQL client, which would probably make a lot of this easier. But I just wanted to make it as simple as possible and not require any additional libraries to make any of these calls. But yes, that's correct. This is how the GraphQL server expects these calls to come in. Everything is coming in as a post, and then the query is the one that contains whether it's a query or a mutation, and the specific attributes that we want to receive, along with the variables that we're getting. So yes, absolutely, totally correct. These are always HTTP post functions or requests. And yeah, this is how we make those GraphQL calls.
Okay, let's throw them into the code and get this working.
Yes, exactly. Okay, so I'm going to just start us off from here. Let's start with the add to do. Here within the add to do, we are creating our to do item. I'm just starting with some random strings for my ID and my user ID, getting the information for my label along with the completion status. And what we were previously doing solely in the front end in memory, we are now going to be doing within by using this create function, right? So we're going to be invoking the create function and then updating our state variables, and might as well go ahead and update our toggle completed. So I'm going to jump over to the toggle completed. Just simply calling the this.update, passing along the ID of the to-do along with the new value of the to-do. And finally, if we go over to the remove to-do, what we'll be doing is instead of solely updating the front-end variable, we are going to be updating the front-end variable, but also making that GraphQL request call to delete the item. And so at this point, what we can do is return over to our database, and we can go ahead and add a to-do. We can see that this is firing off a GraphQL request, and so that was our query, our mutation to create a new to-do. We can update to-do, which will also send over a GraphQL request, and then verify in the database that these are all happening in real time. And so if I show you the database and I refresh it, what we now have is all of those new to-dos that we created in our application, in our database. Our create is working, our update is working, and our delete is working as well. And so that was me just deleting that last one. And so yeah, exactly. We've shown the list from our database. We've added a to-do. We've verified in the database. And so at this point, we have our full CRUD access working. Everything is, we're storing the state fully in our CosmosDB database with our create, read, updates, and deletes.
And with just a few lines of code.
Yeah,
I say
exactly.
that's got to make, for this type of application, that has got to make access so much simpler than it was before. And it gets rid of the issue of the cold start, of course. I know that if my blog site, if nobody's accessed it for 30 minutes, the first person that goes there, they have to wait 10, 15 seconds for that function to warm up before they get the data back. Whereas this is just snappy. It's just there.
Yep, exactly. And so this was just really, we just peeled the first layer of this onion, but we have a lot more functionality that happens under the scenes. We can add authentication and authorization. And then I want to show you how we can also deploy this application very quickly as well and connect it with our database. And so if you're ready, Stacy, I think we should go ahead and do that now.
I'm ready. Let's add some authentication. I like it when my to-do list disappear, but I prefer it if I'm the one that's like finishing them and cleaning it up.
Excellent. Sounds good. Let's do that. And all right. So now that we have our application running with CRUD access to our database, what we'll want to do is add a little bit of authorization.
We don't want everybody to be able to do everything.
Yeah, exactly. We probably don't want that. And so what I propose that we do is what we're going to add is the ability to have specific roles for our users. And depending on this role, our users will be able to have different levels of access to our data. And so just to keep it simple, I'm thinking logged in users will have edit access, but logged out users, users that haven't logged in yet, they will only have read access. How does that sound?
That sounds like a great start to get going, to show what we can do here.
Okay, yeah, sounds good. So let me pull up the code, and great, I'm already in the configuration file. I'll start off in this database connections configuration file. And what we can do is we can head on over to the permissions for our to-do items. And as you can imagine, I came ready, and so I already have this commented out in the code. What we're going to do is we're going to change this array of permissions. And the first permission within this array, what we have is we have the star, which is all of the potential actions. Well, they're all going to be available to authenticated users. Now, this role, and I know, Stacy, you're super familiar with this, but this is one of the two predefined static web apps roles. Every logged in user has the authenticated role, and every logged out user has the anonymous role. And so by using these sort of preset roles, we can go ahead and ensure that someone is logged in order to have edit access, and we'll just leave read access for folks that are logged out.
Using that easy authentication again.
Yeah, exactly.
And looking at this, you can also make this really fine-grained if you want to. For the different sources, you can have different roles. For the different actions, you can have different roles. You can make this as simple or complex as you need for your use case.
Yeah, absolutely, absolutely. And we can change these permissions for every different entity in our database, and so we do have like as much of granularity that we can get with this RBAC. And of course, we're just going to use anonymous and authenticated, but we can have a lot more roles, and that's all coming with that easy auth and role management that we get with static web apps out of the box. So now the one thing is I will have to restart my database connections in order to refresh this configuration file. We're working on that so that we have hot reload, but that's something that's in progress. And so for now, we'll go ahead and restart it. And the other thing that we'll do is within our code, as you know, we'll have access to when a user is logged in, we can access the /auth/me endpoint in order to have access to the client principal, which contains information about the logged in user. And so when the to-do list component will get mounted, we're actually going to call that in order to have access to that data if ever we wanted to use it when we're creating a to-do and referring to the specific user ID later on. So yeah, I am adding this to our function. And now if I go ahead,
look at that, you're logged in.
Refresh the page. So I know for sure that we are getting the information. I am not sure that I am logged in. Let me go ahead and try to make an edit. I'm going to try to make an edit. And yes, you're right. I am logged in. Perfect. And so with this login, I now have access to the read, the update, the delete. And it just so happened that right before this, I logged in through the Static Web Apps, the SWA CLI's emulated login. I added my username. These were the 2 default user roles, and I went ahead and logged in. And so with this login, I have access to this edit experience. But I can also be logged out. And so if I did go ahead and try logging out, what we would see is when I try to make an update, what we'll actually notice is that we get a response from GraphQL indicating that the current user is not authorized to access this resource. And so if we were actually to refresh the page, we'll notice that any of the mutations that I tried to make, so new to do, well, they're not getting persisted in the database, and I'm getting errors in my my application. Now, I haven't necessarily added handling of these errors, but you'll see that we do have that RBAC coming into play and preventing logged out users from having edit access. They still have read access, but they don't necessarily have edit access. We really do need to be logged in to have access to that.
Which is, it is a fantastic first step. And of course, when doing this properly, we'd also use a user ID when we're fetching the list of to-dos. So in your GraphQL query, you can say, hey, only get the ones for this user. And we can make this like a proper app.
Yeah, absolutely. Absolutely. And I think that the to-do list, you're probably often looking for specific to-dos for a specific user. But let's say this was more for a line of business application or something where you're using more roles and it's shared across users. You're very likely to benefit from this RBAC, where a specific role within your different users has access to all of the same permissions. And so,
absolutely.
Yeah, absolutely. Yeah, there's definitely a lot of flexibility there. And I think that the last very interesting step is just how easy it is to deploy all of this. And so what I've done is I've already committed these changes, and I went ahead and pushed to my GitHub repository. So I have a GitHub repository here for this specific demo. Of course, starting off from your starting point, Stacy. But what I've done is I've created a static web app resource with this repository. Now, in this static web app resource, what we can do is we can head on over to the database connection tab. And in here, all we have to do at this point is link our existing database. Now, the reason for this is that we've sort of used the convention folder name with SWA Connections. By default, as build time, that was picked up by the database, the Static Web Apps image, and it was packaged and included in the deployment. And now all of those configurations are available. And so all that we have to do at this point is go ahead and select our database. And that's actually going to go ahead and configure the connection string for it. And at this point, what we can do is head on over to our resource, open up our to-do list. And if I go ahead and show you the network tab and then refresh the page, what you'll notice is that we are getting the GraphQL. We do have that level of authentication that we have added. And so this is me as a logged in user. I have access to new to-dos, but any logged out user would essentially not have access to all that functionality because we've added that RBAC access, right? And so if we tried to edit with a logged out user, we'll see that we actually don't have access. And so our RBAC and our authentication is really taking its place and doing what it needs to do.
And that's it. We have a deployed app. It's working. I can't get over how easy it is to connect the database. It's when you're running through the tutorial in this, I think the biggest issue that I have in my mind is I try and overcomplicate it. It cannot be this easy. What have I missed? But I'm hoping that everybody's seen from this that no, it really is that easy. You really can get your data out that quickly so that your users can have better access.
Yeah, absolutely. And you know, when you think about it, we actually did a lot over the course of this 20-minute demo. We went from a front-end application to storing in a database, to adding authentication and authorization, and then deploying that all within that span of time. And so I think that there's just immense functionality and productivity in this. And we're continuing to build this out and improve all of the different database types and their integrations. We're working with the Azure database teams in order to improve the functionality. And we're also working to improve the local development experience. And so there's actually a lot in store coming with this feature. It's been a blast working on this specific feature. And
I can imagine.
Yeah, exactly.
It's one of those ones that when you look at it when you're done, the value to developers is just obvious once it gets going.
Yeah, absolutely. And so what I do want to have a call out is, as we wrap up, I do want to point to our docs. We've worked really hard to make it as easy as possible to get you from scratch to fully deployed full stack web application. And we have very specific tutorials for all the different database types, along with all of these code snippets. And so some of these code snippets that I showed you earlier and that we added to our code, a lot of them we took it from our docs in order to make it as simple as possible to follow. So yes, I definitely think that if anybody wants to try this out, these are great resources. And during the preview of Database Connections, this feature is actually free for any static web apps that you have. And so I think that there's just tremendous value in this feature. And we've seen the adoption, the feedback has been great, and we've just kept on iterating on it.
Yeah, I can imagine that. It's like I said, it's so easy to get started. No Azure functions, no cold start. Perfect. There's one last thing that I just wanted to say just before we finish off. Really important bit is that word preview. There are some bits in there that we know still needs to be improved to make sure that you really can have even better control over your data than we have right now. It's in preview. It's constantly being updated, and I just can't wait to get using this.
Yeah, absolutely. And the other database types are Azure SQL, MySQL, and PostgreSQL. And so, like you were saying, some of them have a bit more functionality than others. Some of them also have the ability to have REST APIs. So I definitely think that it's worth checking out. I've had a bunch of fun working with those specific database PMs and dev teams in order to add all of this functionality. So yes, definitely. And we keep on iterating during this preview.
Okay, and I think on that note, we are about out of time. I would like to say thank you so much. That's such a fantastic demo. I love demos where you can just really show stuff happening in almost real time, getting it out there to really show how quickly you can do this. Thank you, everybody, for following on for this session. Thank you so much for joining us. And from me, Stacy Cashmore, goodbye. And from Thomas.
And from Thomas, goodbye. Thanks, everyone, for listening. And let's get building. Thanks, everyone.